Hello everyone, welcome back. The most important part in the coordination compound is the complex ion. IUPAC has given a set of rules for the naming of complex ions. The complex ions contains the metal and the ligand. This video is a brief one that gives us an idea about the rules that needs to be followed while naming the ligands in a complex ion. Let's have a look. Let's start. A coordination compound comprises of a positive as well as a negative part. Now, if the complex ion is the positive part, it is to be named first. In the complex ion, ligands are named first. And as I said, this video is essentially about how the ligands have to be named. If the ligands are negatively charged, the name of the ligand has to end with the letter O. If the ligand is positively charged, it has to end with the letters IUM. Neutral ligands, that is ligands without any charge, have no special ending word. Let us see some negative ligands. Chloride. The IUPAC name of this ligand is chloro. As I said, the negative ligand, the name has to end with O. Cyanide becomes cyano. Oxalate, C2O4 having a charge of -2 is oxalato. Oxide having a charge of -2 becomes the oxo group. Sulfite, SO3 2- is sulfito. Carbonate, CO3 2- becomes carbonato. Nitrite, NO2- becomes nitro. Bromide becomes bromo. Hydroxide, OH- ion becomes hydroxo group. Iodide is named as iodo. Thiocyanate is named as thiocyaneto as per the IUPAC nomenclature. Nitride ion, N3- ion is nitrido. NH2- amide is amido. NH2- imide is imido. O2 2- peroxide is peroxo. O2 1- superoxide is superoxo. And nitrite, when the linkage is via oxygen, is nitrito. Neutral ligands, some common neutral ligands which you will come across is carbonyl, water which is known as aqua, ammonia is known as amine in IUPAC nomenclature, En stands for ethylene diamine. Some positive ligands we have NO plus is called nitrosonium, NO2 plus is nitronium, and NH2 NH3 plus is the hydrazinium group. The number of ligands which are bonded to the metal are indicated by the prefix di, tri, tetra and so on. Here one has to take care that if the name of the ligand has a number, then the number of the ligand is indicated by a different prefix. For example, if there are 2 ligands, the prefix used is bis. 3 ligands, the prefix used is tris. 4 ligands, then the prefix used is tetrakis. This part will become clear in one of the following slides. In this example, the positive part is the complex ion. The complex ion is containing the metal cobalt, 2 chloroligands, 1 cyanoligand and 1 amine ligand. As per IUPAC rules, we have to name the ligands first and we'll be giving alphabetical preference to amine. Amine followed by the 2 chloro groups which we'll be naming as dichloro, followed by the cyano group. The naming of the ligands is over. This is followed by the name of the metal and the oxidation state of the metal within brackets. After the positive part has been named, we name the negative part, that is chloride. We can take up another example over here. The complex is COEN3Cl2Cl. The positive part here is the complex ion. It is containing the metal cobalt, ethylene diamine ligand. There are 3 ethylene diamine ligand and there are 2 chloro group. Now, as I said, we will be giving alphabetical preference while naming the ligand. So, chloro group will be given preference, so it becomes dichloro. Ethylene diamine, the name of the ligand itself is having a number. So, we do not use the normal prefix tri to indicate the number of groups bonded to the metal. Here we'll be using the prefix tris instead of tri. So it becomes dichloro tris ethylene diamine. The ligand naming is over. That is followed by the name of the metal cobalt and the oxidation state of the metal. And we name the negative part of the compound chloride. In this slide, we can see the complex K4FeCN6. The positive part comprises of 4 potassium ions and the negative part comprises of FeCN6 having a charge of -4. We name the positive part, that is tetrapotassium. This is followed by the negative part, which is a complex ion. When the complex ion is negatively charged, one must remember that the name of the metal should end with the letters ATE. So here, while naming the complex ion, we say hexacyano because there are 6 cyano groups bonded to the metal. The metal is ferrous, but we will write it as ferrate because the complex ion is negatively charged. So the name of the complex becomes tetrapotassium hexacyanoferrate oxidation state 2. It is ferrate because the complex ion is negative and name of the metal has to end with ATE whenever the complex ion is a negatively charged ion. These are the rules of IUPAC for naming of coordination compounds. Thank you for watching the video. See you soon. Bye-bye.